Good afternoon, everybody. Welcome to Wednesday afternoon of Chem 170 with your host, me, Dr. White. It's our last lecture together. Well, it's sad because it was such a fun semester. I hope it was fun for you. All right, important things. First of all, on Monday, this coming Monday, the 15th at 1 p.m. Actually, I'm just thinking about it now. Probably about 9 a.m. I'll send it out. I will email you the password for the final exam, which you can download once you get the password from the assignment area of D2L. And you'll have until, I'm going to give you a lot of time, the next day afternoon, Tuesday afternoon, the 16th until 3 p.m. to take the final exam and upload your answers as a single PDF file. And I reserve the right to take off 50 points if you don't. This class, I haven't had trouble. Other class I teach at the other school, well, I had to put that in because a couple of people, until I put that in, were sending me JPEG files, which make a lot of work for me I don't need. All right, this won't be an open notes test. None of mine are. Now, it has 32 problems, 18 pages. Some of them are multiple part, never multiple choice. Point breakdown, general knowledge, 30 points. Nomenclature, 62. Reactions, 118. A couple of the reactions, I don't know how many, but only a few will be synthesis problems, which are give the starting materials for the following reaction. The rest are give the organic product or products for the reaction. From the test, the material, points breakdown, test 1, 35, test 2, 60, test 3, 58, and test 4, 53, and finally, new material, 4 points. And if you have any questions during the final, email me on Monday or Tuesday while you're taking it. There'll be no Zoom meeting lectures on Monday the 15th. I better clarify that. Because of the contract ECC has with all faculty members, they don't have a finals week, so you have to show up for classes, even though you've given a final or you're done. So next Monday and Wednesday, I'm going to have Zoom meeting. You don't have to show up. On Monday, you'll be taking the final, maybe. I'm going to be there for 15 minutes. If nobody shows up, I'm out of there. Same thing on Wednesday. If you want to stop by, say hello, feel free to, but you don't have to. Now, by the end of next week, if not earlier than Friday, I will post your final exam scores, all your point totals, and also your final Chem 170 grade in D2L. Now, the official ECC grading system, I think it's called My Access ECC or ECC My Access, one of those. COD and ECC have similar names, but they're sort of flip-flopped on which one has where their school name. But anyways, I'll put that in the same time you'll get the announcement, an email plus the announcement in the school system. The official system usually takes 24 hours after I put it in because they have to refresh the database, and they only do that at night, I believe, nowadays. But whatever is in D2L is your grade. Now, if we look at the final exam as a tiny little gift to you, a tiny little gift, the exam will be set up. Test 1 material be first, then test 2, then test 3, then test 4 material, and finally new material. It's not like if I took a deck of cards and shuffled them. I haven't done that in a while. I haven't played cards in a while. I'm not a big card player. I like other games, but not cards that much. But anyways, so first part of the final will be test 1 material, then test 2, 3, 4, new material. Best way to study for the final use your hourly exams as practice problems. That will cover all but 4 points of the type of questions I can put on the final exam. And just like my practice problems look similar to the questions on the on the hourly exams, the final exam problems will look similar, not the same, as the hourly exams. I'm going to ask you nomenclature, give you a molecule, what's in, things like that. And that's the final exam. And as always, if you ever have any questions about your grade or anything like that, first day of class, I told you there's no such thing as a dumb question in my class or in my universe, my world. That applies to your grade. Afterward, if you have any questions, feel free to contact me. What I will tell you is, if you're within 5 points of a cutoff and you haven't made me mad at you, nobody has in this class, I usually give the student the benefit of the doubt. Now, if you're a couple points out of 500 or 530, come on, I'm going to give it to you. You know who I am by now. All right, that's the final exam. Any questions about what's coming up next week? All right. All right. Personal note, if you should have all gotten online evaluation for Chem 170, I'd appreciate if you fill it out. And I won't see it until next semester. Even when I do, I don't know who filled out what. The other thing I would ask you is, if you like what I've done this semester in Chem 170, please go to Rate My Professor and put something down. And I'll also be honest, if you didn't like what I did this semester, go to Rate My Professor and put something down. If you know anybody who needs Chem 170, I'll be teaching it online this summer and also next fall, and I'll go asynchronous as opposed to this one. And all I'll do is point people in the syllabus to the various lectures for week 1, 2, 3, just like here. And if you go back and look at all my old lectures, you'll see I'm pretty consistent, including the bad jokes. All right, let's finish up. And I'll finish up with test 3 review. And a couple other things I want to talk about that you should know. All right, I talked about test 3 started with carboxylic acids. There's the molecule or the general structure, carbonyl hydroxy group, R group. How do you name them? You take and name the longest chain that contains the carbonyl carbon double bond to oxygen, name it as an alkane. Drop the E, add OIC in the word acid, and the carbonyl carbon is always number 1. Common names you should know. Acetic acid, nobody calls it ethanoic acid, except to say nobody calls it that, and that's the acid in vinegar. Formic acid, when R is a hydrogen, and that's the acid mixed with water and heated that the fire ants use as a defensive weapon. I hope I never see a fire ant in my life. No, thank you. All right, because they can stay down south, and I think they're in Texas or Mexico. I think they're up to Texas. I don't know what other states down south, that area. All right, when R is a benzene ring, IUPAC in their infinite wisdom said, well, chemists, organic chemists have been calling this benzoic acid for eons. We'll make that the IUPAC name. All right, the carboxylic acid is an acid because it's a proton donor. This is the acidic proton, and you react it with a base. For this class, I'll use the hydroxide bases, lithium, sodium, or potassium, and you make the carboxylate anion. Now, a very special reaction. Remember the little rocket ship story I told you? Well, my father taught me how you could take vinegar, acetic acid, where R is methyl, sodium bicarbonate, you can find in baking powder and baking soda. We use baking powder. And this is one of the few reactions I asked you to learn all the products produced. and you get the carboxylate anion, the carboxylic acid, and it forms carbonic acid from the sodium bicarbonate, which immediately breaks down to water and CO2. And the arrow up tells you it's a gas. And I taught you about, remember, oh, I gotta tell you this. My father loved to cook. He was a better cook than my mother, and she was a very good cook. But he never had time because he owned a drugstore. And for many years later on, he was this chief pharmacist at a major hospital in Chicago. But anyways, we had a big deep chest freezer, and we'd make a lot of stuff and freeze it in individual so my mother could take it out. This was before microwaves, let it warm up night before, and we'd have it for dinner. Now, he showed me if you took the little candy rocket ship, then the candy was awful. We threw that out. You put in some vinegar. Oh, wait, I already told that story. This was cooking one. I got sidetracked. And he would make spaghetti sauce the normal way with sauce and tomato paste and tomato sauce. We actually crushed our own tomatoes too. And there was a crusher thing that you turned it and it crushed the tomato. It was really good. And the seasonings. And at the very end, well, first of all, he put a little less salt than you normally would put in. At the very end, he'd put in some baking powder in a big 3-gallon, we have big pots for this pot. He'd put in about a tablespoon or two in a big, and we're talking a big amount. Mix it, you'd see the foam on top, and it would give a much nicer, milder spaghetti sauce because the sodium bicarbonate was reacting with the citric acid that's in the tomatoes to neutralize it. And the bubbles on top was this gas. Oh, the other secret he found out of making the best spaghetti sauce is in a big pot like that, put in like a 1/4 teaspoon of, or a pinch for smaller ones, of cinnamon, just enough to give it a different taste. I had a friend of mine I told that to. He had a smaller pot. He put in a tablespoon of cinnamon. Right. And he called me up and he said, I can't even taste the tomatoes. It's the cinnamon. I said, well, you put way too much. All right, let's move on. How do you make a carboxylic acid? Primary alcohol, oxidized carboxylic acid. If you take an aldehyde, you can oxidize the carboxylic acid. And oh, it's a Grignard reagent, my favorite. And this is where if you take the Grignard reagent, remember X can be chlorine, bromine, or iodine, carbon dioxide, second step water, you get a carboxylic acid that's 1 carbon longer than the Grignard reagent you started with. Next, I talked about esters, a derivative of a carboxylic acid, something made from it. And the ester, there are 2 ways of doing this. The IUPAC is named the R prime in front as the alkyl group it is. IUPAC named the carboxylic acid, if R prime was H, used to make that ester, drop the IC in the word acid and add ATE, the O is already there. Now, I had a very sharp Chem 170 student who said, well, as long as R is not benzene, here's the easier way. When R is not benzene, use B2, because if I say to be or not to be, that's, I did it. That's the question. But anyways, name the alkane from the longest chain with the carbonyl carbon. Drop the AE and add OATE. Now, I asked you to learn one common ester, and that's this one, ethyl acetate. Nobody calls that ethyl ethanoate. How did you get ethyl acetate? Well, the R prime is ethyl. Use the IUPAC or other, but use the common name, not the IUPAC name for the carboxylic acid, acetic acid, drop the IC, add ATE, and you get ethyl acetate. And remember, this is the other molecule used as nail polish remover. Now, at this point, since I taught you about ester nomenclature, we went over carboxylate anion nomenclature. And here we have a carboxylate anion You name M plus as the element it comes from, like lithium, sodium, or potassium. Then, just like the ester, there are two parts. 2A, the IUPAC way, drop the IC in the word acid if this were OH, the carboxylic acid, and now you add ATE. Now, the student's method B2 works also, and R is not benzene. Drop the E, add OATE. Now, as I promised, and I'll keep my promise on the final, with esters and carboxylate anions, when you have a substituent on the R group, the name gets really tricky. I won't do that. I will not have substituents on the R group. Now, esters, and I don't know if you were out over the weekend when we had our one day of summer, if you smelled the flowers, or if you had any vegetables or fruits, most of those are what you taste and smell are esters. How do you make an ester? Fischer esterification, carboxylic acid, alcohol, acid catalyst, H plus acid catalyst, you get an ester. The carbon with the OH, the hydroxy group on R prime, is the carbon with the oxygen on the R prime and the ester. You know something? I've got to share the fun. And here's some fun for you. Let me get my tablet in order and writing position. What two things would you react to make that molecule? Your turn to have some fun. And I hope you have been having fun this semester. And for those of you who haven't really started studying, start studying tomorrow. I'll help you out. And this would be an example of one of the synthesis problems. Now, when I took organic 1 and 2, one of the questions would be like this, except it would be different. It would be like, starting with alcohols, how would you make this compound? That was more challenging. But then again, that was for chem majors. Why was that challenging? I think everybody's done, so my turn. What do we have here? An ester. This is R prime. This is R. Therefore, my carboxylic acid is acetic acid. Remember, that's found in vinegar. And my R prime is this alcohol. Which carbon is this oxygen on? This one. Therefore, this carbon will have the hydroxyl group. And that's how you do it. Oh, I just thought of something I forgot to ask. Did any of you happen to drive by a gas station and think about the gasoline they have contains alkanes? And now you know it also contains ethanol and alcohol. Oh, that's another thing. This I shouldn't have forgotten. By Saturday morning, I will have all labs graded. Also, I'll have the extra credit project graded. I would highly recommend all of you check D2L, your grades, and there are points for the labs. If you have submitted a lab and I have not graded it, email me so I do, and that will help you get a better grade. All right, reactions of esters. You take an ester, react it with acid and water, and you learn this is how your stomach breaks down fats and oils, which are esters. You get back the carboxylic acid plus the alcohol you would have used to make that ester. You take an ester to react with a base, where M can be lithium, sodium, or potassium. Actually works for other bases, but I thought I'd make it simpler for you. You get this carboxylate anion. And then one of my favorite, why? Because we're working with a Grignard reagent, actually two of them. You take an ester, react it with 2 Grignards, second step acid and water, you get 2 products, and the first one, you make something very special, very rare. Not 1, but 2 carbon-carbon single bonds. And you get a second alcohol too. Oh, let's try this out. We have to. And you get 2 products. Your turn. What's the product or products? In this case, it will be products for the following reaction. 3 points each. And for those of you who haven't learned this reaction yet or forgot it, need to relearn it, I'll help you out. And let's wait for everybody to finish. All right, let's take a look at this. What do we have? An ester. Oh, that reminds me. I'm not going to do it today, but I would highly recommend you go back and look at test 2 and 3 and play that fun game, circle and name the functional group, 2 points each. Because if you can't identify a functional group, you're lost. Hopefully you are not lost. All right, we have an ester, and this is R prime. Ooh, carbon, magnesium chloride, a Grignard. And remember, X can be chlorine, bromine, or iodine. In our case, it's chlorine. And that's our triple prime. So my first alcohol, because you got 2 of them, let's go down here where I can have some more room. You'll get our carbon, or not carbon that was the carbonyl, OH. And on each of these, I'll have a T-butyl group. Wow, is this a complex molecule now? And the second alcohol, R prime, that's also a methyl group. So you'll get methanol. And in one simple reaction, this is a simple compound, this is a simple one. I've made a very complex alcohol. Why do I say the Grignard is simple? Because I can make it from an alcohol. This won't be on the test. There are 2 ways. I'll use thionyl chloride. This is how an synthetic organic chemist thinks of things like this. How do you break it down to the simplest things to make? Then add magnesium and you make the Grignard. This is a chlorine. Oh, that was fun. Now you know I'm a synthetic organic chemist. If that's my way of having fun, one of them. All right, let's get back to the review. All right, next I started talking about amines. There's primary, secondary, tertiary amines. And I didn't ask you to learn that. How do you name them? I just taught you the common name. Name each R group as the alkyl group it is in the front and add the word amine. There was one amine I asked you to learn. That's aniline, when you have a benzene ring on NH2. Now, something very near and dear to my heart is help pay for new cars, mortgage, and got me around the world and still gets me money. And that's quaternary ammonium salts. And I only taught you one anion, X is ClBr or iodine. And how do you name that? Name each group as the R group it is in the front and add the word of ammonium halide. If X is Br minus, it's bromide, Cl minus, it's chloride, I minus, it's iodine. And here, ooh, there's a mistake. No, there isn't. This is an amine salt, and R prime can be hydrogen, unlike a quaternary, and you use the same as quaternary ammonium salts. How do you make amines? Alkyl halide plus ammonia and base gets a primary amine. And this, for some reason, got from up here. Let's see if I can move it. Ooh, I can. Move down. I don't know why that happened. Oh no, the halogens bug just got it. All right, primary amine alkyl halide, secondary amine. When you're putting a new R group on there, the carbon in R prime or R double prime or R with the halogen is the carbon the nitrogen is bonded to. Remember, in amines, there's 3 bonds to amines, except in a quaternary or nitrogen, 3 bonds to nitrogen and amine, except quaternary ammonium salts And amine salts have 4 bonds to nitrogen, covalent bonds. Actually, there are 5 because the halogen minus and the N plus is an ionic bond. You take a secondary amine and you react it with alkyl halide base, you get a tertiary amine. And another way of making amines, a nitrile. Remember, this has 2 pi bonds, and that carbon nitrogen triple bond, just like a carbon-carbon triple bond, excess hydrogen, a catalyst, nickel, platinum, or palladium, and you break the 2 pi bonds, and each atom of the triple bond gets 2 hydrogens, and you make a primary amine. And you can write it this way or this way. Now, finally, something very near and dear to my heart, which I'm a world authority in this reaction. I don't think I did this semester. When I put stars by something, that means it's important. When I took notes in grad school and undergrad, I think I started in high school even. And if I put stars in important, that means you really should know this. Well, take a tertiary amine, react with alkyl halide and base, you get a quaternary ammonium salt. Remember, quaternary ammonium salts are used as fabric softeners. Quaternary ammonium salts are antimicrobial compounds, some of them. Remember the mouthwash I brought in? Oh, let's have some fun with this reaction. And give the organic product or products to the following reaction. In case you weren't paying attention or you forgot, that's not polite, paying attention. You do pay attention. I can tell by your scores. And let's wait for everybody to finish. Finish, please. Now, R sub T is just an alkyl group, and I'll talk about it in a second. And I think everybody's finished. What do we have here? Remember, when you look at an organic molecule, look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like that. And I have to throw that in on the last day. What do we have here? Tertiary amine. Remember, this is 2 R groups. I can call this R and R prime. I can call this one methyl R double prime. And this methyl, I can call R triple prime. We get a quaternary ammonium salt, and I'll have 2 tallow groups. That's what R sub T. And one way of writing it, 2 methyl groups, and the anion, this is X, is chloride. And you could have also written it this way. And you could have also written it this way. All would be correct. And for many decades, this was the only molecule, ditallow-dimethyl ammonium chloride, DITMAC, that was used for fabric softeners like Downy or Snuggle. They have a similar one, but cheaper meaning less expensive raw materials that they now use for about the last 10 years. That works just as good and is more environmentally friendly. But when I was in the industry at AXO, this was one of our biggest products. Our sub-T stands for tallow-alkyl. That's the mixture of sterile and oleal C18 with and without a double bond. You have an amine, primary, secondary, and tertiary, and this, our prime and our double prime, one or both or none, can be hydrogen, HX, where X is chlorine, bromine, or iodine. You form the amine salt. Amines are bases. They accept protons. Now, next I started talking about amides. Amide is a carbonyl with an R group and a nitrogen. And on the nitrogen, you have R prime and R double prime. Both R and R double prime can be hydrogen. How do you make an amide? Carboxylic acid, an amine, and that could also be ammonia, because in this reaction, R prime and R double prime can be hydrogen, and you make an amide. Now, once you get an amide, what can you do with it? React it with hydrochloric acid and water, which is in your stomach. And what do you get back? You get back the carboxylic acid you would have used to make that amide, plus the amine salt of the amine you would have used to make that amide. Why? Because when you get the amine from this hydrolysis of an amide, it reacts with the HCl faster than I could do that, and gives you the amine salt. Remember, R and R prime can be hydrogen. If we do base hydrolysis of an amide, we take base, water, get back to carboxylic acid, but in the presence of base, the carboxylic acid gives you the carboxylate anion. And here you also get the amine you would have used to make that amide. Now, I asked you to learn about heterocyclic compounds, and the only thing I asked you to learn was, what is a heterocyclic compound? Excuse me. Getting all choked up over this. And you should know a heterocyclic compound is a ring with carbon and other atoms, such as oxygen and nitrogen. And the only one I asked you to learn was pyridine. Pyridine is the same as benzene, except one of the carbons is a nitrogen. It's aromatic. But this reacts like a tertiary amine, and you can make a quaternary ammonium salt, which is the one in my mouthwash that I use to keep my gums from hurting or being healthy. It keeps them healthy. Because in old days, if I hadn't, I did this, I'd be in tremendous pain. Dental problems, unfortunately, is hereditary in my family. And there we go. Now, since I just went through test number 4, and I just went through the test number 4 review this recently last week, I'm not going to do it now. You can find it on the video and also in the lecture section of D2L. But what I will do is there's 4 things, more than 4 things, but these are 4 important things that you should know leaving my class. Hint, don't you like I can be subtle? Don't answer that. All right, let's go through the 4 things you should know. You should know how to describe with words And a general reaction, what happens in your stomach when you eat something with a fat or oil in it? What's the functional group in a fat or oil? Ester. There's acid and water in your stomach. And what happens in words? Acid hydrolysis of an ester. And the general reaction you learn for test number 3, ester plus acid and water, you get back the carboxylic acid plus the alcohol you would have used to make that ester. Next, I'd like you to know what happens when you eat a carbohydrate. And what's the functional group that holds glucose together in a carbohydrate? An acetal. So in your stomach, there's acid, hydrochloric acid, and water. So that's acid hydrolysis of an acetal. And the general reaction you learned for test number 2, acetal or ketal plus acid and water. Keep your eye on the carbon with 2 oxygens. That's where the fun happens. And you get back the aldehyde or ketone you would have used to make that acetal or ketal, plus the alcohol. For those who need to balance it, you can put 2 there, you don't have to. The reason I do that is I had twins a number of years ago at the other school I taught this, and if I knew that, they'd get upset. And what I don't need is any students, especially twins, both of them getting upset with me. Boy, did they go ballistic if I didn't. They really were upset about that. All right, and the next thing you should know, leaving my class, what happens in your stomach and how do you describe what happens in your stomach when you eat a protein or something with proteins in it? What's the functional group that holds amino acids together in a protein? An amide. Which reminds me, I've got to go through before I let you go today, the amide stuff or the amino acid protein stuff. That won't take long. There's acid and water in your stomach. Acid hydrolysis of an amide. And for test 3, you learn and here I will put HCl because I need a counter anion, or you get back to carboxylic acid plus the amine salt of the amine. You would have used to make that amide. And remember, you don't have to put this down, but I will. And R prime and R double prime, one, both, or none can be hydrogen. Now, the other thing I'd like you to leave my class knowing, you know a lot now about the real world of organic chemistry, but you should know how soap works. You should know soap has a nonpolar tail. And a polar head. Water is the most polar substance in our universe, our planet, and dirt and grease, but let's just put down dirt, is nonpolar. And the most important piece of the puzzle is I even went to red ink because you know it's important when I do it in red in big letters, is light dissolves light. Things that are polar are soluble in polar things. Things that are nonpolar are soluble in nonpolar things. Mix nonpolar and polar and they're not soluble. And if we have dirt, since dirt is nonpolar, the nonpolar tails of the soap are tracked to that. The polar heads stay outside. You form a circular material or thing called the micelle. And the micelle, now since the dirt is surrounded on the outside by the polar heads of soap, micelle looks polar to water. And the micelle looks polar to water. And the micelle, water says to the micelle, I'm polar, you're polar, let's go down the drain together. And they do. And that's how you get your hands clean or anything else you're using, soap or detergent. Now on the final exam, there'll be 4 points on this area. You should know what an amino acid is. And a better way of drawing it, on the alpha carbon, the carbon attached to the carbonyl is your amino group. When R is not hydrogen, then this is chiral. And there's one amino acid, I think it's glycine. I didn't ask you to learn names of amino acids. So when R is not hydrogen, remember a chiral carbon, 4 different groups, 4 different atoms, or a combination of 4 different groups or atoms. When R is not hydrogen, like a methyl group or anything else, that's a chiral carbon, and the amino acid is chiral, which I say here. You should know amino acids can react together in an amide reaction. To form this linkage. I don't call it, because I'm a synthetic organic chemist, but protein chemists call that a peptide bond. And when you link enough of them together, you form a protein. And how do you digest a protein? Well, we already went through that general reaction, amide, HCl, and water. The HCl is the acid in your stomach. Get back the carboxylic acid plus the amine salt you would have used to make that amide. And here I give you an example how you break down 2 amino acids or a amide linkage between 2 amino acids to form the amine salt of the amino acids, which makes it more water soluble in your blood. Isn't Mother Nature amazing what she came with? Instant replay. You should know, leaving my class, how to describe with words in a general reaction what happens when you eat a fat or oil. Acid hydrolysis of an ester, and here's the general reaction. You should know, leaving my class, how to describe with words in a general reaction what happens when you eat a carbohydrate. The key functional group that holds glucose together in a carbohydrate is an acetal functional group, and that's acid hydrolysis of an acetal, and here's the general reaction. You should know, leaving my class, what happens when you eat something that has proteins in it, eating a protein. And you should know how to describe that with words and a general reaction. And here we have acid hydrolysis of an amide. And here's the general reaction. And finally, you should know, how does soap work? Getting your hands or whatever clean. You should know soap has a nonpolar tail, polar head. And water is polar, dirt is nonpolar. And the key to this puzzle, how does soap work? Light dissolves light. And you should know that the soap forms a micelle with the dirt, with the polar heads on the outside. The micelle looks to water polar, and water says to the micelle, I'm polar, you're polar, let's go down the drain together. And they do. On a personal note again, don't forget, please fill out your student evaluation that you should have gotten. It's online. I will not know who you are. In fact, I'm not going to even see it until sometime next semester, sometime this summer. And I still won't know who you are. If you like what I've done this semester, please go to ratemyprofessor.com and say something about that. If you don't like what I did this semester, go to ratemyprofessor.com and say something about that. And now I can say, my world of organic chemistry, I said the first day, is your world of organic chemistry and you don't know about it. But now I can say, my world of organic chemistry is your world of organic chemistry, and you do know about it. And you have knowledge that most people on our planet don't have, not just the United States, the whole planet. And with that, I'll say, thank you very much for being in my class this semester. I wish I had gotten to know some of you better, but still thank you for allowing me to teach you organic chemistry the fun way, not like some schools do it. And with that, I'll say, for the last time this semester, unless you come to my office hour tonight or stop by next week, you don't have to. Gehen gesund, that means go in health in Yiddish, and goodbye.